Alright guys, it's gravity time. So, only one essential question. By the time that you're done watching this video and doing the notes and everything, you should be able to understand what gravity is, a good working definition. So you're going to be able to define gravity and more importantly though, this is the most important part right here, the two variables that affect gravity and how those two variables either cause the force of gravity to go up or the force of gravity between two objects to go down. Okay, so that's the goal. Let's get to it. Now, what is gravity? Okay, make sure you get this definition down right here. Gravity is the attractive force between two objects. Okay, so gravity is going to act to pull two objects towards one another. That's its main goal. All right, now this handsome gentleman right there is Sir Isaac Newton. Now the story of how Sir Isaac Newton discovered gravity was that he was sitting underneath an apple tree contemplating the world, the cosmos, everything. And out of dumb luck, a apple fell from the tree, hit him in the head, and just an epiphany, this spark of information came to him, and he understood everything, and he was able to figure out what gravity is and describe it and all that good stuff. Well, it didn't really happen like that. So let's talk a little bit more about gravity. Now here's the thing, anything and everything that has mass is also going to have gravity, and we kind of talked a lot about this when we were talking about stars and things like that, right? The more massive a star is, the more gravity it's going to have. All right. Now, besides the mass of an object, another thing that's going to be really important when we're talking about the force of gravity is the distance between those two objects. Those are the two variables. Okay, so two variables are going to be the mass of an object, or the mass of the two objects that we're trying to figure out the force between, and the distance between them. Now let's do a little bit of thinking. What if you change the mass of those two objects? What is that going to do to the force of gravity, or the attractive force between those two things? Now, also think about, what if you took the same two objects and you increase the distance between those two objects? What's going to happen to the attractive force between those two objects? Okay. Now here's the thing. We don't have to have like big, huge, really gigantic objects, lots and lots of mass to have force of gravity. Believe it or not, there is a force of attraction, gravity, between you, because you have mass, right? And let's say a pencil on your desk. Okay, the pencil also has mass, and there's a distance between you and the pencil. So technically you should be able to figure out the gravitational attraction between you and your pencil. Okay, now why doesn't the pencil sitting on your desk levitate towards you? Because you have more mass and you should have a higher attraction to it. Well, we are on Earth, and Earth is much more massive than you are, so it's going to have a higher gravitational attraction to everything else. But let's figure out how you can actually calculate gravity. Okay, this looks very scary, this thing right there. Okay, that is a strange looking formula. Looks like you have to do a lot of crazy stuff. Well, what you're going to have to do to figure out this is Fg, force of gravity between two objects. Here are two variables. We have the mass 1, mass 2, because we have two objects, and then we have the distance between them. Okay, so we've got the two things that we need, right? However, since we're dealing with gravity, we have to have this constant, this gravity constant. Now that gravity constant is a very tiny number. It's 6.67 times 10 to the negative 11. Holy cow, that's a small number. Okay, so in our example of the force of gravity between you and your pencil, you know the mass of you, so let's make that mass 1. You know the mass of your pencil, or you could figure it out at least, that is mass 2. All you have to do is multiply those two things together, and then you have to divide that by the distance between you and your pencil. Now here's the tricky part, squared. Okay, then you have to multiply it by that 6.67 times 10 to the negative 11. So this number, this g, is going to make the force of gravity between you and your pencil very, very small. All right. Now here's the other thing to think about. This d squared is the most important factor. And the reason why it's the most important factor is because you have to square the distance. Okay, so if you increase the distance between the two objects just a little bit, that little bit of increase, you have to square it, which is going to make it bigger, making this number down here bigger, okay, which is going to make your force of gravity smaller. So let's talk about those relationships really quick. Now, as the distance between two objects increases, the force of gravity decreases not just a little bit, but the key word is this guy right here, dramatically. Force of gravity between two objects decreases dramatically when you increase the distance between them. But the really interesting thing is, no matter how far apart two objects are, the force of attraction between them never goes away. So, if you threw your pencil, to infinity, there'd still be an attractive force between you and your pencil. It'd be very, very small, but it would still be there. Now, the other thing we kind of have to think about as well is that mass part. Okay, so let's imagine that these two spheres are stars. So we have star 1 and star 2. Now, initially they're this distance apart, and they're going to have a small gravitational attraction towards each other. However, for some reason, star 2 just gets gigantic. Maybe for some reason it just gets a whole bunch of mass from another star or something like that. So now this star 2 is really, really massive, and then star 1 isn't as massive as star 2. What that does is it actually increases the amount of attraction they are going to experience towards one another. Okay? So those are the relationships between distance and mass and gravity. So make sure you understand those two relationships. Those are going to be extremely important. And that's it, guys. That's force of gravity. Watch this as many times as you need.